Okay, our second test, I'm just going to throw this one in here. I think most of you guys would have seen this before. We have our two 12-volt batteries hooked in series here. So we got 24 volts, it'll be about 25 and a half, 26, something like that if they're fully charged. From the positive rail, we're coming out and we're going through our amp meter here, just so we can watch the current coming out of our amp meter. And we're going into the, where have I put that, negative side of this battery, which is not the way it should be. I've wired that up wrong. That should be on the positive side. So from the positive side of our 24 volts through our amp meter to the positive side of this dead battery. It's been sitting for years, has 11.9 volts in it, but it's got no guts in it. That voltage will drop very fast. It is even safe to short this battery out with this little clip lead. You don't even get a spark, and as you can see, we have no voltage. The battery is very cactus. The only reason it's got a little bit of voltage in it at the moment is because I had a bit of a fool around with this not so long ago. So from our 24 volt positive rail through our amp meter into the positive side of the battery, we're coming out of the negative side, and we're going to be going through this 1 ohm 10 watt resistor. I have the scope across just so we can watch the current on our scope as well. That goes into one leg of the motor. We then come out of the other leg of the motor and go to the negative side of our 24 volt battery supply. So what you may have heard in the past is people doing this, and they take an old dead battery and they think there's some magic happening by putting the motor in the system that is bringing the battery back to life, because they will hook the last lead up to their dead battery. The motor won't do anything, and after a little while it starts going. So what I'll do now is I will hook that up, and we can see that the motor, well, it stopped, but it did a little tickle. That is the current flowing through it at the moment. You can see we have the full 24.9 volts, 24.8 volts now across our battery, which is showing us that battery is very unhealthy, and you will see that the current is dancing up and down all over the place. And if you listen really carefully, you can hear the motor ticking away there. Oh, remember, the motor just gave a little turn and then it stopped again. Oh, it's wanting to jump. Oh. So that ticking you can hear is the motor. Now, I'm not sure what's going on in this battery here, but it's like there's little explosions inside of it where the current jumps up and down all over the place, and occasionally you get a decent thump and the motor gives a little spin. But I can hear the motor clicking away there, though it's not moving. And you can see the spikes happening. Oh, and that motor is just taken off, bang, just like that. So it's quite interesting. I don't know what was going on in that battery. It's almost like there was a switch in there, not quite contacting correctly, but as you just seen, all of a sudden, bang, and the motor's taken off. Well, I was in the process of dropping this trace down a bit. And the motor has just died again, slowed right down. Now there's no bad connections here. That's actually something that's taking place in the battery. So what actually happens here, the reason your motor will sit there idle and do nothing, is because the battery, being in very poor condition, has a very high internal resistance. I mean, if we had say 24 volts at 240 milliamps, we'd have roughly an internal resistance of 100 ohms through that battery, minus the 0.2 or 0.3 ohms we may have across those batteries, and a couple of ohms across the motor itself. As you can see, it's dying again. All that jumping around, like someone's turning a switch on and off, is actually happening inside that glass mat battery. So that is a glass mat battery. Or a sealed lead acid battery, as they like to call them. AGM is another name they use. But now our motor's cactus, it stopped. The current is dropping down. So I'm not actually sure what's going on in that battery, but it's jumping all over the place. I can hear the motor ticking away. Oh, there it goes, a little jump. So our current has dropped right down again, and now it's going up and down and up and down. So 24 volts, roughly, 240 milliamps, like I said. The internal resistance inside that battery is going to be about 90 ohms once we subtract the, oh, and there goes the motor again. So now we can see by a voltage across that battery and the current flowing through it, that the internal resistance of the battery has gone down because it's starting to take a charge. However, I'm not sure why. Has that stop-start jumping business going on in there. I haven't seen that before. Normally I use flooded cell batteries, not AGMs, and nothing happens for about 10 minutes, and then the motor slowly gets faster and faster as the current rises and the battery starts to charge. But this AGM battery, glass mat battery, it's doing odd things. So that basically is what happens when people think, oh, fantastic things are happening in this situation. They're not really. All you're doing is reducing the circuit's resistance, allowing more current to flow through the motor. Of course, the more current that flows through the motor, the faster the motor's going to spin. So as your battery charges up, the internal resistance of the battery will go down, which means the series circuit resistance also goes down. Hence the speed of the motor increases, and so does your current. Anyway, well, at least we got to see something a little odd. Never seen current jump up and down like that, like switching on and off inside the battery, but we now know it does because we've seen it on camera. So what will happen now is that battery will keep charging up, maybe it'll just drop out like it did before. The more it charges up, the less the internal resistance becomes, the faster our motor will spin, until such time as that battery is fully charged, providing these two have enough energy to charge that battery and run the motor. Oh, it's just died again. Yeah, so this one's doing some odd things. Like I said, it is an unhealthy battery. There could be all kinds of chemical reactions happening in there that we don't know about. Oh, it's just sped up again. It's good to catch things like this on camera, so if you have some sort of reference to work with, and knowing that you've actually seen this happen before, should it ever arise again. So like I said, I've never seen it happen with a flooded cell battery, which is this type, but with this glass mat battery, or sealed lead acid battery, or AGM battery, whatever you like to call it, all the same thing. Yeah, it's doing what it's doing, jumping up and down all over the place. So this battery at the moment has 14.9 volts across it, 570 odd milliamps flowing through it. The healthier that battery gets, the lower that voltage should drop. Right, thanks for watching. Just wanted to chuck that in there and explain as to what happens as to why your motor could sit idle and then start running all by itself without you touching anything. That's simply the internal resistance of the battery coming down as that battery is charging up. Okay guys, we'll see you for the next video, which is going to be our inverter testing. Power in, power out and power out. One form being to the light bulb out of the inverter, and the other one to our charge battery, and we'll take some measurements and see if there's anything odd happening there. Alright, we'll see you next video.